Greetings everyone! Today we're going to work on graphing and writing hyperbolas, specifically translated. If you haven't yet taken notes on from the origin, please do that first. Today we're going to translate that center point. We're also going to work on writing. If you do have some extra little graphs, that might be helpful, or your marker board. Alrighty, just a quick review. We already took notes on this during our From an Origin video and lesson. So just remembering that the center is where the asymptotes meet. Vertices are our vertices of our parabola. Focus, remember your foci need to be calculated using the correct formula. Our asymptotes are going to be found by plotting our vertex and our b-squared length. Alrighty, our shifting today is going to be involving moving that center point, something you're already familiar with. Just similar with ellipses and circles, we're going to pay attention to what we're adding and subtracting to the x and the y value. Just a quick review, remember a squared is the distance from the center to the vertex. B squared, or B, is going to be the distance from the vertex in the opposite direction, so up to the asymptote. And the C value for our functions is going to be the distance from the center to the focus. Don't forget that your formula is a squared plus b squared. And the way I always remember it, if my conic has a subtraction sign, then my formula has a plus sign, and vice versa. If it's an ellipse with a plus sign, then it's a subtraction sign in my formula. Always the opposite. All right, let's jump straight into the examples. All right, first of all, it's equal to 1. Perfect. It is a subtraction, which informs me that it's a hyperbola. The first value in order matters since its subtraction is a y. Therefore, this is an up-down hyperbola. Center. The center is based on what's being added and subtracted to my x and y. My formula says x plus 4, so it's negative 4. My y says minus 1, so it's plus 1. So negative 4, 1 is my center. So this is our first shifting of a hyperbola. Oops, sorry, my pen. There we go. Vertices. It's vertical. I want to start by talking about my A value. If the value under my y is 25, the A squared is 25, then my A value is positive and negative 5. So I want to go 5 vertically from my center. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Vertically, because I already decided that was the orientation. We want to write these as points. So my x value is the same as my center, right? It's still at negative 4, but it's vertically 1 plus 5 is 6, but I also plotted and could count. And I'd have 1 subtract 5, which is negative 4, or I could just look at what I drew there as well. So those are my vertices. Oops, I'm going to label center as well. Let's use our formula to find c squared, to find our focus length. A squared is 25, b squared is 9. If I add those together, I have 34. Squared root of 34 plus or minus, let's see, 34, does that break down? 4, no, 9, 16, it doesn't. So we're just going to leave it as square root of 34. Let's talk about that distance though. 34 is between 25 and 36. So if it's between those, it's 5 and something. So again, if you're uncomfortable with thinking that through, I mean, you can always use your calculator. If I type in squared root, I'm going to do this as well, of 34, I've got 5.8, right? It's 5 and something. So from the center, we're going to go 5 and something to get to my focus. And I'm going to go from the center 5 down and something to get the focus. So it's really close, right? Oops, I don't know why I wrote 5. Oh my goodness, I need an F there. I was thinking 5 and something. Now, how we write this matters. That is a dot. So we're still existing at -4 on the x-axis. But from our center point of 1, we're adding square root of 34. And from our center point of 1, we're subtracting squared root of 34. So the y value plus square root of 34 and the y value minus square root of 34. That's one of the biggest changes today with these shifts. All right, let's talk about our asymptote equations. This is where that 9 comes into play. B squared is 9. If b squared is 9, then my b value is 3. So from each vertex, I need to go left and right 3. From each vertex, left and right 3. Alrighty, I'm going to draw those asymptotes. It should make a perfect X through the center and through those points. Now these are linear asymptotes, so I need to write them as a line. So now slope-intercept form might not be my friend. I'd have to calculate what the y-intercept is. I don't know. That doesn't sound very good. So first thing I'm going to do, I'm going to identify my slope. Let's take a moment to do that. So I am rising 1, 2, 3, 4, 5. I'm running 3. Look at where I got that. I'm rising 5, running 3. So you don't have to count on a graph. You could calculate it. Rise 5, run 3. So I'm going to have a positive and negative 5/3 slope. You guys, I would use translated form. I would use translated form with my center point. Meaning y equals my slope, which is, I'm going to start with 5/3 x. If my x center point is -4, I can write +4. If my y value is 1, I just tack on the 1 on the end. Just like translated form of a parabola or translated form of any function we've done. The inside value changes signs and the outside value stays as is. Now I can write the same thing and just use a -5/3, use an x, and then use that same center point, a +1 and a +4. Do you see how I did that? So again, I have videos on translated form of a line. You could do point slope form of a line. That just means the ones on the other side. But it's definitely going to be easier to do that than try and figure out a y-intercept. Oh my goodness, I just realized I forgot to draw my hyperbolas on the previous slide. Okay, so please go back, draw those hyperbola shapes through the vertex and along the asymptotes. I did that last time too. All right, let's take a moment to jump to the writing portion of our foldable. All right, given a graph, we want to first maybe mess around with the pieces of our graph. I'm just going to draw on this picture, right? So I'm seeing a center value. If I count 1, 2, 3, 4, 5, 6, 7, 8, I'm seeing 8, 1, 2, 3. Let's talk about vertex. I'm seeing a vertex at 8, 1, which I'm hoping then my other one is at 3, 4, 5. Perfect. That means my distance there is 2. Okay, so let's start setting this up. Should always set this up first. It has to be equal to 1. All right, it has to be subtraction because it's a hyperbola. It has to have a y squared first because it's orientated vertically, up and down. Do you see that? If my center is 8, 3, then my x is going to say -8 and my y is going to say -3. See where I got that? The distance from the center to my vertex was 2. 2 squared is 4. 4 goes under the first fraction, my first denominator. Now I'm going to have to do a little bit of work here to find my b squared value. Okay, so b squared, remember b is the distance from the vertex to the asymptote. Now if I already accounted for the vertical distance, we're looking for a horizontal distance. From this dot, I want to see how far to the asymptote. 1, 2, 3. Let's try the other direction. 1, 2, 3, right? Like you can double check everywhere, but I can perfectly count that that distance is 3, and 3 squared is 9. Doesn't matter which one's bigger. It matters which one comes first. Now, it's not always as easy as looking at a graph. Now, if you can draw a graph, that would be awesome. I am going to draw a sketch because that's how I just take in and understand information. Now, in this particular one, we're using the second and the third quadrant. My vertices exist at -10, 12, and -10, -8. If you have some graphing paper, oh my goodness, that would make it so much easier, or possibly your marker board. Therefore, I'm going to find my center point right away before I do anything here. That means my center point is going to be at -10, and if I find the midpoint, 8 or 12 to 8 would be 20, 10 it would be 2. Okay, I'm just going to start to set this up here just to get ready. It's going to be a subtraction sign. It's going to be equal to 1. It's going to be squareds. It's orientated vertically, so that means the y comes first. My center point, it says x minus 10, so I write plus 10. It says plus 2, so I write minus 2. The distance from the center to the vertex is 10. 10 squared is 100. Wow, I got a lot of information just from that one little piece. Now let's go. Points on the asymptotes exist at -2, 12, and -18, -8. So that's just showing me this asymptote, right? I don't even need the other one because I care about the distance from the vertex to the asymptote. So if I feel like I need, a full picture, could I draw a little more? Sure. Could I even draw some parabolic shapes to help me understand that vertex? Sure. But what I care about right now in this moment is the distance from the vertex to the asymptote horizontally. -10 to -2 is a distance of 8. That's my b value. 8 squared, 64. Okay. This takes a little more practice. You have to be really confident in the basics of a hyperbola. So again, if you are getting lost, draw it out, make a specific drawing, it'll make it easier. Alrighty, let's take a look at example 21. I'm going to draw a little sketch again because that's just how I understand this information the best possible way. It looks like I need third and fourth quadrants. We have vertices that exist at 10, -8, and 0, -8. So if those are my vertices, see how they're horizontal? That means this is going to be an left to right or horizontal hyperbola. It needs to be equal to 1. Like, I like setting it up. It just makes sense to me, right? This is the setup every time for a hyperbola. If my vertices are left and right to each other, that means the x value comes first. From here, I could find the center. Before I even worry about the focus, let's find the center. That means the center would exist at 5, -8. Do you see how I got that? Therefore, x I'm going to write -5, y I'm going to write +8. The focus is at 18, -8, and at -8, -8. So that means it's pretty wide, right? So I'm just going to imagine here for a second. That means my focus, like it's going to be a pretty wide asymptotes through that center point. And if I felt like I needed a little sketch here, right? It's a, oops. It's going to be a very wide hyperbola because of that far focus. So I'm just imagining it. You don't need to do a full sketch if you can get there without that. All right, the distance from the center to the vertex is 5. 5 squared is 25. Okay, the distance of b squared. B squared is the center, or excuse me, the vertex to the asymptote. And that would be a vertical distance, and I don't know what that is. I have to find it using a formula. All right, let's do a little bit of work here. A squared plus b squared equals c squared. A squared is 25. I don't know b, so I don't know b squared. C squared is the distance from the center to the focus from 5 to, I don't know why I wrote negative there, 5 to 18. 5 to 18 is 13. Okay, do you see where I got that from? The distance from the center to the focus is 13, which means we need 13 squared. 13 squared is 169. Let's subtract 25 from 169. That gets me 144. How nice is that? But here's the thing. I don't even need to square root it. The 144 is b squared, which is way larger, right? But that makes sense. I already said, oh, this is going to be really wide. So really wide with a large b squared value makes sense. Again, if you're struggling with this, please use an actual graph to help you interpret it. Alrighty, let's take a look at the last example we're going to do today in your foldable. We have a very interesting situation here where we just know points on the asymptotes and the foci. So again, I'm visual. I'm going to use a picture. I'm seeing first and fourth quadrant here. I'm going to do my setup first. It's meaning it's going to be a subtraction sign because it's a hyperbola today, equal to 1, quantity squared. Let's talk about foci first. I'm going to deal with that. So 9, 3 is a focus, and 9, -7 is a focus. Now, this does help me find my center point because the center is always between the focus and the vertices, and so it's going to exist at 9, and it looks like I need to go a distance of 5, so -2. So vertical, I can already see that if my foci are aligned vertically, it's going to be vertical. So that means y comes first, x comes second. Let's talk about the center point. If my x is positive 9, I write -9. If my y value is -2, I write +2. I don't know the distance from my center to my vertex, and I don't know vertex to asymptote. So let's deal with those other points here. We have 12, 2, 12, 2, and we have 6, -6. Which means that would be an asymptote that goes through the center point. Okay, that means I can find a horizontal distance to the vertical distance to find my vertex, right? So what that means is there is a vertical change of 1, which means this dot is going to exist at 2, right? Same y value. And its x value is going to be 9. Do you see how I came up with that? I went horizontally, which means the y value stays the same, all the way to the vertical pieces that we're talking about that all lie along 9. I could do the same thing in the other direction, right? If I create a horizontal distance, it would exist at 6, -6. So if I go vertically, sorry, I just like spaced out there for a second. My x value will still be 9, and my y value has a distance of 1, so that makes sense, -6. That's my focus. Okay, I now know, or excuse me, that's my vertex. Sorry, that's my vertex. That means I now know, I got excited, sorry. I now know the distance from the center to the vertex. If you need a little bit of a sketch here, right? If that's my vertex and I know I'm vertically aligned or vertically orientated, it's going to look something like this, right? All right, center to vertex has a distance based on my numbers of 4. 4 squared is 16. I can fill that in. If I want a color match here, it should be a blue. Blue 16. Remember that b squared is the distance from the vertex to the asymptote, which is what I just created on my graph. From 9 to 12, it was a distance of 3. Or from 6 to 9, it was a distance of 3. And 3 squared is 9. Again, if you need to, please use an actual graph to help you interpret, understand, and figure out. As always with conics, we don't have a lot of examples, and so I do have 2 extras here. I'm going to leave this one. If you need it, feel free to use it. But I would rather spend time on this one because it looks a little different. First of all, it's a hyperbola because it's subtraction and it's equal to 1. Next, I'm going to make note that the x value is first. Therefore, this is a left to right parabola. The center point exists at, well, there's nothing being added to the x, so it's 0. Looks a little different, right? The y value says -2, so I write +2. So 0, 2 is my center. Okay, so it looks a little different, just shift it up a little bit. Vertices, it's left to right. I have an a squared value of 25, which means a equals 5. So from the center, I want to go 5 to the right, and I want to go 5 to the left. That's my vertices. So I exist at 5, 2 and -5, 2. So the fact that that was 0 actually kind of helped a little, right? Next, let's use our equation. 25 plus 4 is 29. If I take the squared root of that, 29 does not break down, but square root of 29 is just a little more than 5. So a little more than 5 has me between the 5 and the 6. That would be my focus. Oops. And we want to write that as points. So our x value is 0, kind of convenient, right? Positive square root of 29, comma 2, and negative square root of 29, comma 2. All right, make sure you write those as points. Asymptote equations. The first thing I need to do is acknowledge this 4 here, right? So that means that b equals 2. So we're going to go vertically from each vertex 2 units, which allows us to create our slant asymptotes. And before I forget, like I did earlier, oh my goodness, let's draw those parabolic shapes. Cruise along, go through the vertex, cruise along. Go along, go through the vertex, cruise along. Okay, Make sure you got arrows on the end too. Our equations though. Okay, I know my y-intercept handy. I'm going to do slope-intercept form, meaning y equals, I have a slope of rise 2, run 5, 2/5 does not reduce, x plus 0, because that's my y-intercept. No, my y-intercept's 2, 0 comma 2, so plus 2, and y equals negative 2/5 x plus 2. Okay, I think it's important to write them separate just because we're writing all our points separate. I should have 2 of each. I think it just makes it more clear. Alrighty, I know these are long ones. You're doing great. You're doing awesome. Bear with me. Keep up the hard work. Let me know if you have any questions. Check out Google Classroom to see what your task is. Let me know if you need anything. And until next time, have a good one.